Hey everybody, welcome back. Today we're talking about the most misunderstood topics in all of math, logarithms. A lot of people hear that word and immediately zone out, but I promise you by the end of this video, logarithms are going to feel completely natural. We're going to go from what is even this to actually using them. Let's go. Let's start with something you already know, exponents. 2 to the third power equals 8. That's easy, right? Now here's the question that a logarithm answers. What power do I need to raise 2 in order to get 8? The answer is 3, and that's exactly what a logarithm tells you. Right? We write it out like this. Log base of 2 of 8 is equal to 3. When it's read out loud, it's read out loud like log base 2 of 8. It just means 2 to what power gives me 8, which is 3. That's it. A logarithm is just a question about an exponent. So if exponents say here is the base and the power, find the result. Logarithms say here's the base and find the result and find the power. They're two sides of the same coin. Let's read a few more examples so the notations click. Log base of 10 of thousands equal to 3. Why is that? Give me 5 seconds. Pause the video if you need more time, but I'm going to reveal the answer now. That's because 10 to the power 3 is equal to 1000. Log base 2 of 32 is equal to 5. Why is that? I'll give you 5 seconds, and if you need more time, pause the video. It's because 2 to the power 5 is equal to 32. Log base 3 of 9 is equal to 2. I'll let you think for 5 seconds, but if you need more time, pause the video. It's because 3 squared is equal to 9. Now, two special bases come up constantly. When you see log written without a base, it almost always means base 10. This is called a common logarithm. When you see ln, that means natural logarithm with the base e, approximately 2.718. You'll see ln or natural log everywhere in science and calculus, but the concept is identical. It's still asking for an experiment. So here's some real life examples. The Richter scale for earthquakes is logarithmic. A magnitude 7 quake is not twice as strong as a magnitude 6. It is 10 times stronger. Decibels in sound, same deal. Every 10 decibels is 10 times more intense. pH in chemistry, the acidity scale is logarithmic. Compound interest, logarithms tell you how long it takes for money to double. In computer science, when someone says an algorithm runs O, or log n, time, that means it's incredibly efficient. Logarithms tame huge numbers. Now let's talk about the rules that make logs actually useful for calculation. There are three big ones. Rule 1, the product rule. Log A multiplied by B is equal to log A plus log B. Multiplying two numbers inside a log turns into adding their logs. This is huge. It's why scientists used log tables before calculating existed. Multiplication becomes addition much easier. Rule 2, the quotient rule. Log A divided by B is equal to log A minus log B. Division inside of a log becomes subtraction outside. Rule number 3, the power rule. Log a to the power n is equal to n multiplied by log a. An exponent inside of a log we pulled out as a multiplier. This one is especially useful for solving equations where the variable is in an exponent. Let's see that in action. Suppose you need to solve 2 to the power x is equal to 50. So you're supposed to take the log of both sides, and then you get x multiplied by log 2 is equal to log 50. X X equals log 50 divided by log 2, so x will equal 5.64. That's how you crack equations when the variable is trapped in the exponent without logarithms. It's trapped inside the exponent. Without logarithms, you're stuck. Super quick, let me bust 3 mistakes I see constantly. Mistake 1. Log A plus B is not equal to log A plus log B. The product rule works for multiplication, not addition. You just can't split a log over a sum. Mistake 2. Log A multiplied by log B is not equal to log A plus B. There's no rule that combines two separate logs that are being multiplied together. These do not simplify nicely. Mistake 3. Forgetting that a log of a negative number is undefined in real numbers. You cannot raise a positive base to any power and get a negative result, so it's not a valid import for log. Memorize these three and you'll avoid most log errors on a test. So let's recap what we covered today. A logarithm answers the question, what exponent gives me this number? Log b of x equal y means b to the power y equal x. The three key rules: product, quotient, power. Logs appear everywhere in science, engineering, and computing because they handle exponential scales. The best way to get comfortable with logs is to practice translating back and forth between exponential and logarithmic form until it feels automatic. Do that for 20 minutes and you'll be in great shape. If this helped, hit the like and subscribe button. Next video, we're going to be going into graphing logarithm functions, which is where this stuff gets really visual and interesting. See you then.